All right, ladies and gentlemen, we're going to do the chromatography lab today. So what we're going to do first is talk about chromatography, what it is, and hopefully you have your lab pulled up in front of you while you're watching this video. Chromatography is the separation of mixtures. So what it is that as we're going to do this lab, we're going to put a marker line down at the bottom of this paper, and the pigments will travel up the paper. Now, if it's made up of two different pigments, the larger molecules won't travel as fast and will travel slowly. The smaller molecules will travel up much more quickly. So what we're going to do is we're going to test what pigments are in these three markers. Is this green, the seafoam green, is it only this green color, or is it a mixture of two different pigments or three different pigments? Same thing for the brown and the purple. Okay, so what we're going to do now is we're going to talk about what else can you do for a chromatography. Well, this is used a lot of different places, especially in food sciences. So you think about milk, and we talk about milk as being a homogeneous mixture. You've got the protein, you've got the sugars, you have the water, you have calcium and all the vitamins that are in there. What we can do with chromatography is separate those molecules and tell, is there water in there? Is there sugars? And so on and so forth. We can see what is in that mixture. And hopefully we'll do it by the end of this video here today. So the first thing I'm going to do is I already have my chromatography strips cut out. What we're going to do now is make our salt water solution. So we're going to use just about a spoonful of salt into some water using our glass stir rod. Now, these little rubber boots right here, we're not going to mix with this part. What we're going to do is we're going to mix with the glass rod. This rubber boot allows it to not spin when it's on the table, so that way it doesn't roll off and hit the ground and break on me. Okay, so we're going to go ahead and just mix this together. It is totally fine that there's crystals at the bottom. We're just making a super saturated solution of salt water. Okay. Next thing we're going to do is we're going to take our markers and we're going to make a nice heavy mark, not at the bottom, but some distance away from the bottom. Because what we want is we want these markers to soak up the saltwater solution, but not soak in. And last but surely not least, we have purple. Okay, so what I'm going to do now is I'm going to put these strips in the solution, but the solution will not go above this marker level. The solution is going to sit kind of at this halfway point right here. And what's going to happen is that saltwater solution is going to travel up the paper. As it travels up the paper, that physical property we talked about of solubility, of things dissolving, is going to dissolve or pick up that pigment and then carry it up the paper. The smaller pigments will go up faster, the larger pigments will go up slower, but as that salt water travels up the paper, it will separate this mixture. That's if this purple marker is a mixture indeed of two different pigments. So what I'm going to do is go ahead and just set those in there, and I'm going to fold it over on the side. That way it doesn't, my purple mixture doesn't get in my solution all the way. We don't want to go above that line. Okay. Takes a little bit of finesse to figure it out. We can see those layers already starting to separate on me. Okay. Alrighty, after some finagling, I was able to get all three of those across, and the solution is not above that marker level. And so what we're going to do is we're going to wait about 15 minutes in total. We're going to let that solution give plenty of time to move up, and as you can barely see, this middle brown right here is starting to not look like brown anymore. Okay, so what is going on exactly? And so this is talking about solubility, and that's the whole purpose of chromatography, is looking at are substances dissolvable in a liquid. And since we used these ultra wash clean washable markers, these are absolutely dissolvable in water and even more dissolvable in salt water. So what this is that as these pigments are soak up in the water, they're soluble, they dissolve, they travel up the paper. Okay, we're also going to hit pause on this video, and in about 15 minutes we'll see these nice and dried. We'll talk about them, and then you can finish up your lab procedures and post-lab questions at home. Alrighty, it has been about 15 minutes, and so what we see so far is that the solution has traveled up about as far as it's going to go. It could go a little further, but after 15 minutes we call it done there. So what do we see? We see that the seafoam green color is a mixture of yellow, green, and blue. There's a lot of blue pigment, some green, and there's a very little bit of yellow. So this is a homogeneous mixture of those three colors. What do we notice about purple? Purple is over here and has a little bit of pink and looks like just some more purple. And so to make this a nice dark purple, looks like it's a mixture of two different pigments. My favorite one, however, is the brown. So brown looks like it is a mixture of a bunch of different colors. What do we see? We see a lot of red, a little bit of blue, some greens, and some yellows. And so what we can see so far is that all three of these markers are homogeneous mixtures of different pigments, and we were able to separate their pigments by the smallest molecule being at the top because it was able to travel faster, and then the larger ones towards the bottom. Okay, I believe this is all you're going to need when it comes to answering this chromatography lab. Good luck. If you have any questions, let me know. You can shoot me an email or type down in the comment section on this video. Good luck, and I will see you hopefully soon.